Lights have been used as safety warning devices on work zone projects since the early 1900s. The first safety warning lamps were manufactured by the R.E. Dietz Company of Syracuse, New York, and used in the early 1900s for laying trolley tracks and oiling roads. These were called an 8-day kerosene lamp. During the 1930s, lamps were beefed up and with a larger fuel capacity. Some were called night watch, and mostly used in cities and towns around hazards like laying bricks, cobblestones, and other road projects. Dietz was the leading manufacturer of lamps from the early 1900s up to 1950. The next generation of lights came in the 1940s and were called smudge pots. Fueled by kerosene, they could burn continuously for 30 days. It was more efficient to let them burn than to turn them off and on. The light on the wick would flicker, giving the appearance of the first flashing light. Some of the early manufacturers of smudge pots were Dietz, Escoflair, Toledo Press Steel, and Lucky Light. Smudge pots were used from the 40s up to the 70s. The pots, when struck by a vehicle, careened like bowling balls and were the cause of many grass fires, as well as traffic accidents. In the 50s, smaller smudge pots were introduced as warning lights for short-duration projects. This is probably the first lighted aero panel ever manufactured. It was used by utilities in the early 40s. The first battery-operated portable warning device was developed in California in 1948 by Neo Flasher. They signed up franchised operators such as Warning Lights of Illinois, Indiana, and Minnesota, NABCO in Seattle, and Don Stabler, who later would form Protection Services. For a battery case, they used a World War II ammunition box, which was cheap and in plentiful supply. They dipped the box in red paint for color. They used components from electric fence controllers, which had a mechanical flashing system. For a lens, they found a 4-inch diameter bidirectional truck turn signal at an auto supply store. They built 250 units for a California project, placed them on the job site, and the story goes that over 100 lights were stolen in the first 2 days of the project. On the right is the next portable light. Introduced by Neo Flasher in 1949, it used a smaller battery case with an electric fence timer. With the introduction of transistors by Texas Instruments in the 1950s, other companies entered the portable light business. R.E. Dietz, Peralta, Hudson, Toledo Steel, Star Flasher, UC Light, Northern Signal, Safety Flare, and Electronic Specialties. The unreliable electric fence timers were replaced by transistor lights with solid-state circuitry, and in 1955, another generation of lights was born with the 6-volt flasher unit. Moving into the 1960s, Peralta was the first to provide a 7-inch round lens, which was soon to become a national standard. Metal cases were still being used, and the first tamper-proof case was introduced by Parmac with a light called the Guard Light. Head assemblies were primarily supplied by Stimsonite. An early 1960s flashing light consisted of a butane container with a lens attached. Used a lantern wick for the flame. Some called it the bomb, as it could be quite a hazard on the road. It was manufactured by Warning Lights Incorporated of San Antonio, Texas. About this time, the industry realized it needed light standards and specifications. The ITE, Institute of Traffic Engineers, was asked to do this. A light specification committee was formed in 1960. In 1964, the 6-volt steady burn light was introduced. In 1966, ITE published the first detailed standard specification for lights. It called for a 7-inch diameter lens with an outer half-inch ring of reflective area. The lights were identified and labeled. Type A flashing, Type C steady burn, Type B high-intensity 24-hour flashing advance warning light. The B and C were tested after burning 7 days, and A tested after burning 14 days. The early B lights were all metal cases, 12-volt constant 24-hour flash, powered by one very large battery. They were very heavy and cumbersome. Some of these used a 40-watt light bulb. Peralta introduced a detachable B light where the heavy battery case would be left on the ground. EMCO Light introduced a special plastic insert for the B battery box, which used 8 each 6-volt batteries in lieu of the 12-volt battery. Protection Services had a unique telescopic B light with interlocking tiers, which could be raised to a height of 8 feet. Protection Services also had the first vertical panel. It was manufactured by ESCO Light and powered with 2 6-volt batteries. The 2 lenses would flash back and forth. Today's B lights are much lighter with all plastic cases, powered with 2 6-volt batteries. Plastic cases were introduced in the late 60s by Peralta. Warning Lights of Illinois manufactured the Tough Light. Electric lights used an aluminum case. Colt, ESCO, and Cassell went to plastic, as did Echo and Decker Supply. In the early 70s, EMCO Light was established with a full line of warning devices, with lenses and cases interchangeable with Peralta. Although photocells were introduced in the 60s, early light failure was still a problem, with replacement of batteries and bulbs required every 2 to 3 weeks. Bulb manufacturers would not produce a 6-volt bulb without orders in the tens of millions, which required the undervoltage 5-volt bulb to be changed with the batteries. This resulted in many projects having some, or many, or all of the lights not burning, which in the 80s resulted in many states removing or limiting the use of lights from road projects. In 1983, the Manual on Uniform Traffic Control Devices added clear nighttime visibility requirements of 3,000 feet for A and C lights and 1,000 feet for B lights without sun interference. The next generation leap came in the early 90s with the acceptance of the LED light-emitting diode as a replacement for the 5-volt bulb light. This drastically improved the light life from 2 to 3 weeks to 12 to 17 weeks. The LED eliminates lamp failure and uses fewer amps, resulting in longer life. In the late 90s, the Texas Department of Transportation wanted a better way to move traffic over at lane closures and approached EMCO Light to develop a system. The first attempt was a hard wire system, and the DOT commissioned TTI, Texas Transportation Institute, to come up with a recommendation. After 3 years of studies and tests, TTI, working with EMCO Light's engineers, developed a wireless, battery-operated, sequential light system. The channeling devices are lit continuously with a steady burn Type C mode, upon the request of the FHWA, and an alternating, momentary flash Type B mode. Test reports are available. In 2000, technology was now being advanced with a circuitry allowing the use of D-cell batteries, resulting in 20 to 25 weeks of durability with 4 alkaline D cells. On the right is the D-cell tube light. It's designed to work with vertical panels and in traffic cones. In 2001, the ITE Specification Committee next looked at and wrote specifications for the D lights as a 360-degree light, and as you can see on the right, particularly for use on drums where truck traffic misoriented the lights. It is now approved for use. With a 3-volt air battery, it should have a life of 7 months. Technology is really accelerating now. The most dramatic improvement in light durability and performance occurred in 2002 with a change in circuitry, allowing the use of a 3-volt air battery. Outdoor tests in Chicago with 1 battery indicate a life expectancy of over 18 months for the A and C lights. Although the air battery cost is slightly higher, it is more than offset by its dramatic performance and longevity. New for 2004 is the ADA Type 1 audible light. It was designed to meet Section 6D01 of the new Manual on Uniform Traffic Control Devices, which supports the most desirable way to provide information to pedestrians with visual disabilities that is equivalent to visual signage for notification of sidewalk closures is a speech message provided by an audible information device. Devices that provide speech messages in response to passive pedestrian actuation are the most desirable. The Type ADA1 is a voice programmable message light. It is capable of carrying a 20-second long message that you program to meet your needs and is activated by a motion sensor. The Type ADA1 is also equipped with a Type D 360-degree flashing warning device for visual notification. The new lights help protect the environment of the landfills. What used to fill a wheelbarrow with 88 batteries now uses only one. Today's lights are crash tested to meet the requirements of NCHRP 350. We can sum up a century of lights: an 8-day kerosene lamp in 1902, a 730-day battery-powered light in 2002. With nighttime road construction on the increase, with more emphasis on safety, with dramatic light performance, with an aging population that needs a better nighttime warning system, and with a proven need of guidance for the disabled, let us bring the lights back. Let us keep the lights on.